It's pleasure to introduce myself to you. This is B. Indra Manikanta, studying in ACA section, bearing roll number 23 BQ1A0426 in our esteemed college. Today I am here to represent a video recording semiconductors. In semiconductors, what are the types of semiconductors and uses of semiconductors and applications, and use of majorly silicon semiconductor in our daily life, and finally conclusion. So first come to what is a semiconductor. A semiconductor is a material with electric conductivity between conductors and insulators. This unique property allows it to conduct electricity under certain conditions but not others, making it essential in modern electronics. This is the major future of the semiconductor. Means the conductivity of the semiconductor lies between conductor and insulator, and basically semiconductors have very less resistance and moderate conductivity when compared to insulators. So next, some of the key characteristics of semiconductors. Controlled conductivity. Semiconductors can be modified to enhance conductivity by adding some impurities, which we will study next. There are majorly two types of semiconductors. One is p-type semiconductor and another one is n-type semiconductor. Next, applications. Semiconductors used in transistors, diodes and integrated circuits, found in many devices in daily life. Next we go to use of semiconductor in our daily life. Semiconductors are the fundamental to everyone, and it included in every device such as smartphones, computers, television, display screens, household appliances. Next, automobiles, medical equipment, solar panels, LED lighting, internet and communication. So in these many aspects semiconductors are involved. So next come to major classification. Types of semiconductors. Semiconductors are mainly classified into two types. First one, intrinsic semiconductor, and then next one, extrinsic semiconductor. First one, intrinsic semiconductor. The definition of intrinsic semiconductor is pure silicon and germanium, because in intrinsic semiconductors there are no impurities. The property of intrinsic semiconductor. At room temperature, intrinsic semiconductors have a very low conductivity. Their conductivity can increase when energy is supplied. Means we can say that when external energy is given, the conductivity of intrinsic semiconductors properties will change. Next, applications. It is very rarely used due to its low conductivity. Typically used as base of a doping to create extrinsic semiconductors. Means it is a base to create extrinsic semiconductor. Next, extrinsic semiconductor. The definition of extrinsic semiconductor is these are semiconductors that have been doped with impurities to enhance their electrical conductivity. It tells that when we add some certain impurities to an extrinsic semiconductor, the conductivity of that semiconductor increases. In this extrinsic semiconductor, there are two types. One is n-type semiconductor, another one is p-type semiconductor. So first come to n-type semiconductor. These are doped with the elements of 5 group elements. Example for 5 group elements is phosphorus and arsenic. When we add 5 group elements, it has excess electrons. So next, p-type semiconductor. These are the conductors which are doped with 3A group elements like boron, gallium. Then in p-type semiconductors we find holes, whereas in n-type semiconductors we find electrons. And the application of extrinsic semiconductor is used in diodes, transistors and ICs. Next, advantages of semiconductors. Semiconductors offer several advantages in our daily life, which makes our daily life easy. First one is compact and lightweight. Semiconductors majorly are very lightweight. Due to this lightweight, we can use wherever we want. Next one is energy efficiency. They consume less power compared to other electrical components, leading to longer battery life in devices and low electrical usage. Next, high reliability. Semiconductors have a long operational life and less prone to physical wear and tear. Next, fast switching and high speed. When we use a semiconductor in our device, it can enhance our speed of the device and make highly efficiency and high speed, and it can increase the speed of the device. Next, cost effective production. Basically, when we need in there is no replacement of semiconductors because they are of high efficiency, low cost, means somewhat these are economically cheap when compared to other components. Next, temperature sensitivity. Their conductivity can control by the temperature. Next, like this there are wide range of applications, like they are using microchips, solar panels, LED lighting, and etc. Next, when we come to applications of semiconductor have a wide range of applications across multiple industries due to their versatile properties. Here are the some properties we discuss. First one is using computers and smartphones. Semiconductors are integral in CPUs, GPUs, and memory chips and storage, powering nearly all computing and tasking. Next, we use in telecommunication equipment. Semiconductors are used in devices like modems, routers, and satellites, enabling high-speed internet and data. Means it can increase the speed of the electrical component. Next, third one, we come to automotive industry. Semiconductors are used in sensors, engine control units, infotainment systems, and safety features such as airbag, anti-locking systems. Nowadays, there are accidents are increasing due to taking very less precautions while driving. So when we use semiconductors in cars like airbags, so it can reduce the damage. So this is one of the application of semiconductor. Next, medical equipment, diagnostic and monitoring device, like when we take MRI scanner or CT scanners, these semiconductors are plays a crucial role. Next, renewable energy. In renewable energy, we majorly talk about solar panels. In solar panels, we use semiconductors. Next, military and aerospace. In nowadays, each country should have some basic security. So, when we come to security, we need weapons and different navigation weapons, and we should increase our communication for. So in that process, semiconductors will help us. Next, LED lighting and display technology. Semiconductors in LEDs provide energy sufficient lighting solutions and high quality displays in TVs. Nowadays, the quality of the TVs are increasing due to the efficiency usage of semiconductors. Next, smart home and IoT devices. Means nowadays, without moving ourselves, we can control each and every device in our home by using smart AI, like that. In that smart AI, we use semiconductors and transistors. So these are the applications of semiconductors. Next, nowadays silicon semiconductor is playing a major key role because it has abundance and cost effectiveness when compared to other semiconductors used. When compared to other elements used as semiconductors, somewhat silicon is we can find everywhere and it is cost effective. Next, it has thermal stability when compared to germanium. Next, well established technology means we know each and every component of silicon. Next, high electron mobility. Next, oxide layer emission. Next, compatibility, and so on, so etc. So finally, I conclude semiconductors. In conclusion, semiconductors are essential components in modern technology, enabling countless applications from consumer electronics and healthcare to renewable energy and everywhere. industrial automation. Their unique ability to control efficient electric conductivity makes them versatile and crucial for devices requiring compact and efficient high speed. As advancements of semiconductors technology continue, such as development of smaller, more powerful chips and eco-friendly materials, we can expect further innovation, and further future is mainly depend on these semiconductors. So thank you for giving this golden opportunity. Have a good day.